Hello class, welcome to section 2.7. Today we're going to look at right triangle trig. The good news is that you guys have worked with right triangle trig before, so this is not the first time that you'll be seeing this. So your goal is that you'll be able to find missing sides and angles of right triangles. And one thing is, and we'll get to this later in this course, is that you will use this in solving problems using navigation, surveying, astronomy, and measuring distances. So just a reminder, what is sine, what is cosine, what is cosecant, what is secant, and what is cotangent? I'm just going to start out by writing down SOHCAHTOA. Okay, that's going to help us. SOHCAHTOA. Okay, so sine is our opposite over our hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Okay, the way you find your opposite side and your adjacent side is by whatever angle the problem is asking you for. Okay, your hypotenuse will always be the same, so I might even just label that right away. Your hypotenuse is always across from your 90-degree angle. It's always also your longest side. It's your hypotenuse. Then if I'm looking at angle A, which is right here, the side across from it, that is your opposite, and then the last side is your adjacent. Now if I had this triangle again, and I asked you, oops, that's a C. If I asked you to find sine of angle B, your sides would be labeled differently, okay? Because if I look at angle B, my opposite would be this side. Okay. So your opposite and adjacent can change depending on the angle you are looking at. Another thing I want to point out is you can only use SOHCAHTOA for right triangles. So it has to be a right triangle. And then finally, just some triangle labeling. You always label the angles with the capital letter, and the side across from it is always the lowercase letter of that angle. Okay. So let's go ahead and find sine. Sine is opposite over hypotenuse. So if I look at this triangle I'm given here, its opposite would be A over my hypotenuse, which is C. Okay. Cosine would be adjacent over hypotenuse, so B over C. And then tangent of angle A is opposite over adjacent, so A over B. And then I just have to remember cosecant. Who is cosecant the reciprocal of? Is the reciprocal of sine. So we just have to go ahead and flip this. Or it's 1 over A over B. We can also just flip it right away. So we have C over A. Then we have secant is the reciprocal of cosine. And so that one's going to be C over B. And then lastly, we have tangent, which is the reciprocal, cotangent, which is the reciprocal of tangent, so it would be B over A. Okay. So those are our trig ratios. Okay. For today's lesson, you're going to want to grab your graphing calculator. So if you haven't, pause the video, go grab your calculator, and then come back. Hopefully you took a second and grabbed it. On your calculator, you should confirm before I move any further that your mode, okay, is in degrees. So hit mode. If you have a newer calculator, you can also look at the top of the screen and it probably already says degree at top, but if it says radian, you need to change it into degree. The way you change it on there is you hit mode and then you go down and over and make sure that degree is like highlighted, you know, has that black box around it, and then hit enter on it. Then in order to get out of this screen, you're going to click second and then mode, because the button quit is right above mode. So second and then mode. And then you'll be back to your home screen. So make sure you are in degree mode. So just a reminder, our trig ratios, we're going to write them out again. We got SOHCAHTOA. And for this, we are looking at angle, they call it theta. So this is a new variable, variable, that's what I want to say. This is a new variable. Theta, you'll see it a lot. Usually theta pertains to when you're finding an angle. Okay, so theta, that is the variable that we typically use. So sine, remember, is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. And then these, you just have to go ahead, they're the reciprocal, so you flip them. Okay, so hypotenuse over opposite. Secant is the reciprocal of cosine, hypotenuse over adjacent, and tangent, the reciprocal of cotangent then is a reciprocal of tangent, so adjacent over opposite. Okay. So today we're going to talk about solving a right triangle, and what this means is we got to find all the parts of the triangle. That got underlined bad. So all of them. We must find all of them. That means there are 3 angles and 3 sides. We got to know all of those values. So if I ask you guys to solve a triangle, that means you have to find all the parts. So solving this right triangle, I'm going to start with the easiest thing. I have a 35-degree angle. This is really a 90-degree angle. I could find this angle right here right away. Okay, the way you find the angle is, we know all angles in a triangle got to add up to 180. So what I would do is 90 plus 35 is 125. So I would take 180 minus 125, which leaves me with 55. So that means that the measure of angle Y, notation, measure of angle Y, equals 55 degrees. So there we go. So now I have 4 pieces of information. I got all 3 angles and a side. Now I just have to find X and Z to have my triangle solved all the way. So I always recommend using the information that you were given. Okay, so I'm going to use the angle of 35, just in case I made a silly mistake on finding my 55. So this is 35, so based off my 35, I'm going to label all of my sides. This is my opposite, and then I like to do my hypotenuse right away. And then the other one's my adjacent. And I'm going to write down, so, ka, toa. Let's just go in alphabetical order and solve for X first. Okay, if I look here, I am going to have my opposite, and I'm going to use the side that I know. I know this side is 10, because otherwise I would have too many unknown variables. So adjacent. So who uses opposite and adjacent? Not sine, not cosine, but tangent. So I set this up. It's always the trig function and then the angle measurement. So tangent of 35 degrees is equal to X over 10. Then you just have to solve and get X by itself. So it's currently X divided by 10, so I'd multiply both sides by 10. So X equals 10 tangent of 35 degrees. And you will type that into your calculator, and I really need you to actually type it in and make sure you can get the correct answer. I can't do it on my screen because I don't have access to my graphing calculator when I'm at home. Okay, so 10 times tangent of 35, and then round to 3 decimal places. When you do this, you should get 7.002. And that's a side length, so we're just going to say, leave it as that. We don't know the unit measurements. Okay, so there's X. So now I have 3 angles, 2 sides, so my last one I need is to find my third side, which is my hypotenuse. So once again, I'm not going to use my opposite, because what if I made a mistake finding it? So I am going to use my adjacent and my hypotenuse. So who uses adjacent and hypotenuse? That is cosine. Cosine of 35 degrees equals your adjacent, which is 10, over your hypotenuse, which is Z. This one requires a little bit more work, but the more we do of it, the quicker it will get. So in order to solve this, the first thing I would do is get Z out of the denominator by timesing both sides by Z. Those will cancel. Now I have Z times cosine of 35 degrees equals 10. Then to get Z by itself, it's Z times cosine, so I would divide by cosine of 35 degrees. So you type in 10 divided by, and then cosine of 35 degrees, and when you round to 3 decimals, when you type it in, you should get 12.208. And that would be your answer for example 1. You have solved for everything. Okay. Here are just some more practice problems. We're solving for X. So if I want to get X by itself, it's currently being divided by 12, so I would times both sides by 12. So X equals 12 sine of 40 degrees. And if you type that into your calculator and round to 3 decimals, you should get 7.713. The next one, once again, X is in the bottom, so we'll times by X. So we have X cosine of 18 degrees equals 62. And then we'd have to go ahead and divide by cosine of 18. So if you guys want to notice, the X and the cosine switch spots. So if you wanted to think about the variables in the denominator, how you could skip to getting to your final answer, or kind of cutting down on steps, you times by X and then you're going to end up dividing. Okay, so if you type this into your calculator, you will get that X is equal to, let's see, 65.191. And then C, we have tangent of 62 equals x over 100, or x divided by 110. So we're going to multiply by 110 to get x by itself. So on your calculator, you type in x equals 110. Well, you don't type the x in. You type in 110 times tangent of 62. And when you do this, you should get 206.880. So that is example 2. If you have any questions, let me know. Okay. Otherwise, we're moving on to example 3. It says solve the right triangle. So if I'm solving it, I need to have basically 6 pieces of information. Okay. So right now I see I have 2 pieces of information. I know that I have little b is 40, and then I have a is 38 degrees and 40 minutes. So we haven't done this in a while, but this is 38 degrees and 40 minutes. So what we're going to do is you got 2 options, okay? We can do the finding out what this answer is, okay, using good old algebra, you know, and writing it out, or you can use your calculator. You could do, it's really going to be 180, and I'm going to subtract this 90. So then that means that these 2 angles, this one and this one, have to add up to 90 degrees. So we're finding the complement, which we did earlier, okay? So we could write it all out. We would have 90 degrees and 0 minutes, and we need to subtract 38 degrees and 40 minutes. So remember what we did is we're like, okay, I need to subtract this. I can't from 0, so I borrow from my 90, which makes this now 89 degrees, and then there are 60 minutes. So then it's 60 minus 40, so 20 minutes. And then if you do 89 minus 38, we will get 51 degrees. Okay, so that tells me what angle B is. Okay, so capital B, 51 degrees, 20 minutes. If you want to do it on your calculator, you would just type in 90 minus this. And remember, the way you find all of those values are using the button above apps angle. Okay. Pretty sure they are all in there. Yeah, they're all in there. Okay. So, there's angle B. So now I have 3 pieces of information. Actually, I have 4. I know what angle C is too. C is equal to 90 degrees. So now I have to find the other sides. I need to find side C and side A. So I was given side or angle A. So this is going to be my opposite. This is my hypotenuse, and then this one will be my adjacent. So what I'm going to do is I'm going to find A first. I have my opposite and I have my adjacent. So using SOHCAHTOA, who uses opposite and adjacent, that would be tangent of the angle, so it's 38 degrees and 40 minutes. And that equals A over 40. So A equals, you times both sides by 40, so A will equal 40 times tangent of 38 degrees and 40 minutes. So you have to type that in. So remember, to find your degree and to find your minute, you're going to have to go to that angle button. Okay, so you go tangent and use those. When you type it in, and you really truly need to practice typing this one in. So A equals, you should get 32.008 when you type that all in. Okay. So now I have side A, side B, I need to find side C. So if I go to find side C, I would be having my hypotenuse and my adjacent. So I would have cosine of the angle 38 degrees 40 minutes equals, that was 40 over C. Kind of like we said before, I would times both sides by C, and then I would have to divide by my cosine. So C equals 40 divided by cosine 38 degrees 40 minutes. And then you would type this into your calculator again. And you should get that C is equal to 51.230. And those are all of my values in my right triangle. So that's example 3. Okay. Now example 4, we're switching it up. We're solving for theta. Okay. Whenever you're trying to find an angle, you use the inverse functions. Those are the buttons above sine, above cosine, above tangent, okay? So in order to get rid of sine, you'd have to do sine inverse on both sides. So I'm going to write it out. I really do sine inverse of this, and then I do sine inverse of this. The inverse and sine undo each other, which leaves me with theta equals sine inverse of 3/7. Okay, you type this into your calculator and you will get, I'm going to check this really quick, sorry. You will have 3 divided by 7. You should get 25.377. Okay, but that's in degrees. This one says to round to the nearest minute. So what I need to do is convert this into degrees, minutes, and seconds. So if you go into angle and down to number 4 again, where is that button? DMS. DMS. And then convert it, you will get 25, so theta is equal to 25 degrees, 22 minutes, and 36 point something seconds. So it's 37 seconds. So we need to determine if we should round this up or not, okay? This is in seconds. I would say to myself, how many seconds are in a minute? There are 60 seconds. So when we talk about rounding up numbers, if it's 0.5 or higher, we round up, otherwise we stay the same. Half of 60 seconds is 30. So if it's greater than 30 seconds, round up. If it's less than 30 seconds, you're going to stay the same. Okay, so this is 37, so greater than 30, so we're going to go ahead and round up to 23. So our theta answer for A is 25 degrees and 23 minutes. That would be the nearest minute. Okay, just follow your rules of rounding there. Okay, so B, in order to solve for theta, you would type in cosine inverse of 5/8. And when you do that, and you convert this into, so cosine of 5 divided by 8, you will get 51.3178, and then I'm going to go second and get to my angle and convert it into degrees and minutes, minutes, and seconds. And so in degrees, minutes, seconds, we get 51 degrees, 19 minutes, and 4.125 seconds. So I'm going to say 4 seconds. 4 is less than 30, so 19 will stay the same. So my answer for this one is 51 degrees and 19, I labeled that wrong, sorry, minutes. There's B. And lastly, C, to get theta by itself, I do tangent inverse. So theta equals tangent inverse of 11/4. When you type in tangent inverse of 11 divided by 4, you will get 70.01689. Okay, I'm going to change that into degrees, minutes, and seconds. So I have 70 degrees, 1 minute, and 0.817 seconds. So this is less than 30, so this will be my answer. So theta equals 70 degrees. I'm going to write 1 minute. Looks nicer. There you go. Okay, so there is solving for theta, and then we're using our degrees, minutes, and seconds. Okay. Now, on our next example, we're given a triangle, and this time we need to solve for theta. Okay, so we need to figure out if we're using sine, if we're using cosine, if we're using tangent. So we're solving for theta, so I will look at theta, and I'm going to label my opposite right away. Okay, that's the one right across from it. This is my opposite. And then I like to do my hypotenuse, which is across from my 90. And then I always do my adjacent last. Okay, so adjacent. And I look and I see, okay, my numbers are here and here. So that tells me my opposite and adjacent. So thinking back to SOHCAHTOA, who uses opposite and adjacent? Tangent. So it is tangent of theta equals 43 over 18. To solve for theta, we do tangent inverse over 18. And then when you type it in, and it says round to the nearest degree, minutes, and seconds, so I would give you a second, type it in. Convert it to degrees, minutes, and seconds, and round it accordingly. Your answer should be 67 degrees and 17 minutes. Okay. On to B then, same thing, looking at theta. This is my opposite. This is my hypotenuse. This is my adjacent. So I don't have any values for my opposite, but I have my hypotenuse and my adjacent. And who uses that? Cosine. So it's cosine of theta equals 6 over 15. So to get theta by itself, you do cosine inverse of 6 over 15. And your final answer, when you type it in, move it to degrees, minutes, seconds, and round, you should get 66 degrees, 25 minutes. So there is example 5. Okay. And that will be it for our notes today. Today you guys will have the right triangle trig worksheet. So you can either print it off or you can do it on your iPad. That's up to you. Otherwise, if you have questions, feel free to message me on Schoology. Have a good day.